Good morning. We're ready to learn about some data quality, Purview and Databricks. Yay! Right, yeah, let's rock this. Okay, good morning. My name is East. If you think direction, you found me. I'm a principal consultant at Advanced Analytics. I love data and I love technology, and I love helping people access both of these. Outside of work, I like to swim, cycle, and spend time with my young family. So for today, what we're going to do is going to step through what we mean by data quality. We're going to then have a look at why data quality is important, then go through Purview, Databricks, and then go through a bit of a demo. Okay. So what do we actually mean when it comes to data quality? It's effectively the expectation that everything is as it should be with regards to data. So how much do we think bad data might cost? This headline figure of $3 trillion was estimated in 2016 for the US alone. And it was calculated based upon the manual effort required to correct or work around bad data, as well as the direct impact of really poorly informed decisions. As that volume of data has grown over time, and the overall quality of data probably hasn't improved that much, this headline estimate can only have increased. What about Northern Power Grid? Bad data quality got them soundly mocked on social media and could have very well bankrupted them if that person had cashed the check. So we've got a real life instance there of quite poor data quality. So why is it important? And so why is it costing economies trillions of dollars every year? Largely manual effort. So the manual effort required in correcting data is rarely done in the source. So it only really compounds the problem because it's the same fixes that apply time and time again, but always when users are interacting with the data rather than correcting them once and for all. In an increasingly decision-driven world, misinformed decisions can have lasting consequences on organizations. So poor data quality can create mistrust, lead to poor decision-making, and in turn lead to very poor outcomes. Among these poor outcomes is reputational risk. So Northern Power Grid had a very clear reputational risk. They got mocked. But it could also lead to things like GDPR issues. So duplication of data could result in a customer being contacted twice, leading to frustration and mistrust, as well as wasted time and resources. On the flip side, missing or incorrect data can result in contacting the wrong person or the wrong information being provided to that individual. And then that leads them to question your organization, the accuracy of your data, and then creating further mistrust towards your organization. And finally, missed opportunities. So poor data quality can lead to missing opportunities or causing failures in service provision. Inaccurate or out-of-date data may result in unnecessary service provision, whereas high data quality could outline more valuable opportunities. So where we might have poor data quality, by improving that data quality over time, we can then engage more valuable opportunities. With poor data quality, you're less able to assess your own effectiveness and whether your money and resources are used in the best way. Again, improving that data quality will increase your own operational effectiveness. So how do we determine what is data quality? So there are some internationally industry-aligned measures on this, and these are the data quality dimensions. So the first of these is completeness. So it's the percentage of data that is missing within a data set. So this could be for a product, missing estimated delivery dates on a product description. But if most product descriptions have those estimated delivery dates, that data is incomplete, and you're not providing the same level of service to your customers. However, not all attributes need completeness, and that's for an organization and a data steward to assess which ones need to be complete and which ones don't need to be complete. To assess completeness, we're effectively using data profiling. It's not currently a feature of Purview, but we can have a look at some of the options available to us when it comes to the demo. Next, we have timeliness. So how up-to-date or conversely antiquated your data is at any given moment. So if we might have information on our customers dating back to 2008, and we're now in 2022, we potentially got an issue with timeliness as well as completeness of the data. And when determining data quality, the timeliness dimension can have quite a tremendous impact on the overall accuracy and viability and reliability of your data. Next, we have validity, and that refers to data following specific formats, rules, and processes. So, for example, many systems will ask for a customer's birth date. However, if the customer doesn't provide that birth date in a format that's expected, so think US and ISO date formats, the level of data quality automatically becomes compromised. So if data can follow a particular rule, it can be assessed quite nicely. Like completeness, this isn't yet a feature of Purview, but we can explore how we can use existing features of Purview, like the catalog and the glossary, to enable this functionality. Next, we have integrity, and that refers to the level of which information is reliable and trustworthy. So if your database has an email address assigned to a customer, and it turns out that customer supplied a fake email address, you got an issue of integrity with your data. Then we have uniqueness. So that's a data quality characteristic more often than not associated with customer profiles, such as a single customer view. So greater accuracy in compiling unique customer information, including associated performance analytics and attributes related to customer company products and marketing campaigns, is a cornerstone of more profitability and success with customers. And finally, we have consistency, and that is more often associated with analytics. So it's ensuring that the source of the information collected is being captured in that consistent manner. So if the system is collecting pertinent data in one field, and that field then switches, we've now got an issue with consistency. So Purview. So Purview is ultimately a data governance tool, and data governance comes with a series of personas. So you have information security. They're interested in everything information security related. Next, we have data governors, data owners, who are interested in the overall process and ownership of data. Then we have data stewards, so who are interested in data quality metrics, lineage, and profiling. And then we have data engineers, who are going to be more interested in the rules, the dependency change, and the metadata that comes from data. And then finally, we have data consumers, so those who are looking for new data sets, how they're able to connect to those data sets, and also any documentation that may or may not exist around data. So Purview is made up of two broad parts. The first one is the actual platform, so the underlying technology. And that has a data map. And the data map provides a fast and precise scanning across the data estate. So this is actually your lineage, which is being created. So it's the lineage of where data is sourced, where it's targeted, and when it's transformed. And that lineage is tracked at both an asset or a table level, as well as a column level as well for some supported sources. Next, we have the Purview Studio. So this is where you're actually going to be interacting with Purview on the whole. The big part of it is data catalog. So that's going to be where all your data sources are, so that the right people can discover the right sources and understand where the data is. It's also where glossary terms are defined, classification rules are applied, and any other classification labels as well. Finally, there's data insights, which is effectively like a broad reporting across your data estate. We're not going to go into data insights as part of this session, but it's quite a useful feature for having that bird's eye view across your estate. So when it comes to mapping in the estate, we have typically a very nice, easy data journey where we have a single source, it's going through a single data platform, it's being transformed in a singular process to feed a single report. We can map that, and that's a really nice use case for data cataloging. However, the actual reality of this is that there are hundreds of reports, there are thousands of databases of different varieties, on-prem, on clouds, custom processes, and inevitably, there's always going to be an access database. So Purview has the concepts of collections, which are effectively grouping for sources. So you could group them by domain, you could group them by where they live, whether it's on-prem, clouds, which type of clouds. And we have our sources, and these are going to be source systems like servers or data lakes. And underneath a source, we have assets. And assets get produced when we apply a scan. And assets have the following attributes. They have descriptions, classifications, lineage, glossary terms, all applied to them. So in our hierarchy of assets, while we have our source, which is a server, it is also an asset. So is our database, so is our schema, and so is our table. So why do we have this structure? Ultimately, it's down to the Apache Atlas and its API. So Apache Atlas is a true open source project. It maintains open standards for metadata management, and metadata management is what good data governance tools are all about. So it allows organizations to build a data catalog, classify their assets, and govern those assets in a collaborative way. But Atlas provides a bare minimum for organizations to basically meet regulatory requirements, but also the opportunity to build upon it. And we'll see this acceptability with Purview when it comes to creating custom glossary terms, which we'll then use to drive our data quality framework. So, asset tagging and assets. So, asset tagging is going to be like, what is this thing? So here we have a credit card, and highlighted we have a name. But what's in a name? With a person's name, we can be very prescriptive with it, particularly from a security aspect. But when it comes to wider context, like a customer billing name, we need to know how to deal with it. And this is where asset tagging comes in. We have two types. We have the classification, or what is it, and that's done automatically as part of a scan. And then we have glossary terms, and that's providing that wider context. That's the what does it mean, how should it be used. That's done manually. And here we have an example of classifications and glossary terms associated with our assets at a column level. So in terms of our personas, how well are we covered in terms of Purview as it currently stands today? Absolutely nailed it. From Versec, they can do everything they want to do with it. They can lock down assets. They know who has access to what. They know where data exists. Data owners, they can start applying they have a data dictionary, a business glossary, and they can start applying their development standards to it. Data stewards, they're not really that covered. They have data lineage. They don't have the others. Data engineers, with lineage, we've got some dependency chains. And consumers, we've got some aspects with data discovery and data connectivity, but lacking on the documentation aspect. So for our demo purposes, we're going to focus on the highlighted areas and discover how we can enhance the existing functionality of Purview. So, Databricks. So Databricks is Spark as a service, and some of you are probably thinking, what the hell is Spark? So Spark is an open source in-memory processing engine that is widely used to process data on cloud-based data platforms. Databricks itself is a unified engine, and that means that data engineers, data scientists, data analysts can all use the same tool and have that option to use different languages, but within the same engine. It also uses distributed compute. So here we have our cluster and our data. We issue a command in a notebook to the driver, and that then gets pushed to each worker, thereby reading the data from our data lake, store into a data frame. We can then shuffle or aggregate the data onto a single worker, returning it to the driver, with the results visually returned to the notebook. Okay, demo time. Okay, so this is the Purview workspace. So the first thing we're going to do is we're going to create a collection. We could use the root collection, but for demo purposes, we're just going to create a collection and group things for data quality purposes in here. And we'll call that data quality. Oh, sorry. I need to turn the zoom on. So we got our name here. Okay. So we're now going to try and scan a SQL database that we've got set up. And for that, we need to add some credentials. And for that, we're going to use key vault-backed credentials as well. So we're going to add a key vault, and we're just going to select it from our existing subscriptions. And what we need to do is also need to grant the managed identity access to key vault itself. Okay, so just move over here. So we're going to give it the get and list permissions because these are the bare minimum permissions it needs. Okay. And just throwing a little warning just to remind us, just to double check that we've done it. Okay, so we've now got our Key Vault connection, so we can go retrieve some secrets from Key Vault. And we'll create a new credential. It's going to be SQL authentication, not best practice, but for ease of purposes, it is nice and straightforward. Okay. Okay, so within our collection, we have a little box for registering assets. That's going to bring up a list of current connections, and we can go and connect to our Azure SQL database that we've got. Okay, so it's when we then click scan, that's when it's then going to ask for credentials. So we can then actually authorize and connect to our sources. We'll turn off this preview bit because it requires additional permissions on the database for it to work. All right. Okay, that's going to take a while to run, so we'll, hang on. Yeah, we'll just deselect a few of the options. So you only want the base tables. We have an option here to add scan rules. So we're just going to use the system defaults, but we can also, with time, create custom rule sets. And those rule sets will apply your classification, so how you want to treat that data, how you want to tag that data in an automated way. But we'll just use the default ones, and they're generally quite useful. We'll just have it once. Okay, right, that's going to run away in the background. Takes quite a while to do. So we'll go and create our glossary terms and build out our data quality framework using the glossary. So at the top, we have term templates. And term templates are kind of how you extend the glossary to your needs and purposes. So there are system ones, but we're going to use custom one. And we'll call this data quality as a term template. And we can add different attributes to it. So for our demo, we're going to add 3 attributes. You can add as many as few as you want to kind of make it work for you. But our first one is going to be called data quality rule. It is going to be a free text fields because this is where we're actually going to be writing some SQL. And that's all we're going to be doing is basically lots of SQL. Add another attribute. Okay. So with this next one, we're going to be having single choices. So our first one is going to be advise, and then our second one is going to be quarantine. So why these options? So this is going to tell the framework how to treat data. Is it of poor quality, but quality that is acceptable to retain within the main data sets? Or is it of such horrendous quality that you just need to park it, remove it, and isolate it from everything else? So we're giving users and data stewards the options. And then finally, data quality failure reason. So why has it failed? Okay. Okay, right, now we're ready to create some terms. So the first one we're going to do is just use the system default, and we're going to be doing this to just group all the data quality rules together. So we're going to call this one data quality rules. So as inspiring as the name is. I'm just going to switch over to the hierarchical view because it's a bit easier to view things. So our first one we're going to use is our data quality rule, so our custom term template. So we're going to call this one quarantine empty or null columns. So we're expecting that of any data quality, for any missing or null values, for these particular attributes, we want to just park them and isolate them from everything else. So our data quality failure reason is because column is null or empty. And our data quality rule, and this is where we're then going to write some SQL, but with some placeholders instead. So you've got column is null or column. Ooh. So what we've done is we've written some SQL, but with some placeholders. So instead of specifying for each individual column, we've just got a 0 wrapped in some curly braces, so that when it comes to applying the data quality rules, we can just inject the column name that we've associated within Purview. So it streamlines things a lot more nicely, so we can reuse these rules time and time again. And then finally select the rule type. Okay, right. Going to do here's what some I made earlier in good old Blue Peter fashion. And that's mainly because I can't write regex, but regex is actually quite useful. So we've got things like advising if an email address isn't quite right. So we've got, again, just a normal SQL expression, but using regex to say if it doesn't follow these rules, do something about it. Likewise, with a phone number, we can do the same as well. So again, it's a regular expression. So if you can build regular expressions, or if you can write SQL, you can create and broaden out your data quality rules. Okay, let's double check on our scan. It's doing its thing. We've discovered some stuff. Okay, let's go and have a look at the catalog. So we've discovered some assets, and they're predominantly tables, but down at the bottom we have our schema, we have our database, and we have our server. So they're all still assets in the grand scheme of things. But when it comes to the actual schemas associated with these assets, we have classifications, which again picked up as part of the automated scan, and we can add these, we can confirm these, we can remove these as well. But for our purposes, we're going to keep them as they are, and we can start editing the schema. And we can do this just by associating with glossary terms using drop-downs. So we can add as many or as few of these rules as we want, and they can get applied within Databricks as they do. So we can say that email address, we're going to say advise if it doesn't meet the standards, and we can quarantine it if it is empty. Same with first name and last name. And we can go through and through and through until it all gets populated. Okay. So over to Databricks, and on the whole, we are using a lot of Apache Atlas, and that is the library which connects to the Atlas API, and that's the one that drives everything. So while we're using Databricks here, you could use Synapse, you could even just use a vanilla version of Spark, or indeed just use a Python script running on-prem, connecting to your own custom ETL tools. So let's import these bits. So next we're just going to import some secrets from Key Vault. So that is quite specific to Databricks. But next we are going to just authenticate against Purview. Again, just using normal API connections. One of the beauties of connecting to Purview is that we can use Purview to define our metadata for use for processing. So Purview has a defined schema for assets when they get scanned, and we can then scrape that information, do some type conversions so that it's going to be more native for it, and then we can use that later on. So if you have a look here, we can kind of pass through our fully qualified name, which is, just a reminder, which is this bit here, down the bottom. That's our fully qualified name. So it's a unique association for every asset within Purview. So we got our schema and its outputs, and at this stage, it's just a string. It doesn't mean anything. It only means something when we start applying it to the data. But we've at least been able to retrieve it and use it in an automated fashion. So next, we are going to be connecting to the same schema, but we're then going to be only retrieving the columns that have any glossary terms associated with them. So in our example, we have our 3 columns, and we have 2 unique GUIDs. So we can tell already that we're going to be reusing some of these rules already. So we're going to be taking that schema, and we're then going to be applying those transformation rules. And this is where we're then going to be doing column injection, where we're then saying, right, instead of having placeholders, we now got column names. And we've now got how we're going to handle it, and the reasons for why we're rejecting these data. We can also use the classifications. So what a customer is, kind of whether it's a phone number, an email address, or a first name. So we could use these for external validators. So anything which is going to be checking an email address or a phone number. Conversely, we could also use something like Presidio to go and mask the data as well. So I think Mike Dobin has quite a few bits on Presidio, if you're interested in more of that. Okay. So when it comes to using the actual schema that we're going to get from Purview, we're going to use the same functions that we've just seen. So Spark is very good at inferring data types, but it doesn't always get it right. So we have a modified date here, but and it looks normal. It looks like a date, but when we actually print out the schema, we'll see that a modified date is actually a string. So it's not interpreting the data how we'd actually like to interpret the data. So that's why it kind of needs an upfront schema. And that's kind of where you'd either have to hand crank one or just use Purview to get one for you. So you can now read that same data, and our modified date looks very similar to the other one, but we now got an actual like timestamp encoding with it. So it's treating it the way we expect it to. And just quickly write that out. Okay. Right. So when it comes then to actually applying these rules and applying data quality, again, we're just going to be connecting to the same API connections we went through earlier. But we're also going to be stepping through a little transformation script. And this little transformation script is, again, using more SQL, but it's saying, case when conditions are met, then do something about it. Otherwise, don't do anything. So again, just using lots of SQL to drive all this, even though we are on the surface of it not using SQL. So when it comes to profiling, we have quite a few different options. We have, so when you display a data frame, typically comes out as a table. As we've seen, it's just tabular formats, but we can it also comes with inbuilt data profiling. And it's quite nice. It has things like counts, percentage of missing values, means, standard deviations, all the things you kind of expect from data profiling. And this is the same as using an inbuilt Databricks utilities called dbutils. But what both of these approaches and what many other data profiling approaches provide is an in-script HTML visualization of profiling, which is not actually that easy to get hold of. It's useful when you're in the application, but you can't retrieve it for other purposes, so you can't remove it from the application itself. So there is another option. So each data frame has an inbuilt describe function. And describe is quite useful. It has counts, it has means, it has mins and max. But unfortunately, it's also missing percentages. But we can use it. We can sort of fill in the gaps. But it's still missing data. But it also will provide it for the columns along the top. So for a consistent manner, we just want to unpivot it, make sure that it's all going to be presented in a consistent format, and do it that way. OK. So when it comes to the actual application of data quality, we are passing through our data frame. We're going to say, this is the entity it's associated with, as well as kind of that path for Purview. So we're going to get the Purview schema. We're then going to return the transformation rules, profile the data, apply those transformation rules, so we're then actually having a physical score of that data, do lots of filtering to separate the different data bits, and then we're going to write out our scores, write out our profile, and return our clean data set. And then finally, we can start writing data out as well. So our first example, we're going to be using address. So we've got our fully qualified name. We've got where it exists in the lake, where it needs to go in the lake, and where any bad data needs to go as well. So just read that in. Add some decorations. OK. And now we're going to score the data. So we have our columns, we have our rules, and we have how we're going to treat them and why they're being rejected. So we can now see in our actual data that is returned. how it's been treated. So in this example, we're just logically rejecting them. We're saying quality it's not great, but it's not that bad either. So you can keep it in there, but just be aware that the column is empty, and our column is address line 2, which address line 2 you kind of expect and forgive being empty. Okay. Just write that out. Okay. So our next example is sales order detail. So a bit more transactional data. So I'm going to read it in, add some decorations, and let's go clean it. Okay, so our one and only rule is to reject anything where our unit price discount is greater than 0. We shouldn't be giving discounts out, so someone's done a bad job giving money away for free. So we're just going to say, right, this is awful, park it, exclude it, we don't want to report on it. So if we go have a look, we can see that we have a unit price discount of greater than 0, and we can see that we've completely rejected it, or we will be rejecting it when we start writing it out. Okay. So all those different activities have fed into a wider data structure, which has then led to a Power BI report. So we have our timeliness of when things are being ingested into the system. So as we're ingesting every single day, we expect that to be 0, which we got. However, the data we've actually got is actually old. So our timeliness dimension here is awful. Our overall data quality score isn't great, but at least we now have a baseline from which we can now improve and monitor our data quality. We can start having a look at our sales order detail, and we can say that it's actually okay. We have a look at other attributes, say like product, where product, our data quality score for it is awful, where we've basically advised everything is just don't touch it. And other bits as well. So we can start building upon this and start reporting on it and start making actions upon the actual quality of our data. Okay. So how well are we covered? So from a data stewards and data engineering perspective, we've kind of removed a lot of those issues. So we can do data quality metrics. We can report on that. We can monitor it. We can do some sort of profiling. Again, things still need to be improved. From an engineering perspective, we've got those processing rules. So while we've got them lined up for data quality, we can extend that to any type of transformation rule that might need to be applied, and we're also receiving some engineering metadata, so where that schema is and how we need to treat it. We've not tackled data consumers, and I don't intend to at this stage. So now I've got about 5 minutes for Q&A. So while we're doing that, please provide some feedback. Feedback is important to me to improve, but also for every 10 feedback submissions, we're going to plant a tree, and you also get entered into a prize draw to win something cool.
So there's only one question on the Q&A, and I kind of know the answer to it. Is there a roadmap available for Purview, like there is for Power BI, Power Platform?
Thank you. Thank you very much for the applause. So the question was, is there a roadmap available for Purview like there is with Power BI? The answer is yes. That is with the Microsoft product team. At the moment, I believe it's quite hush-hush, so I can't share it, but I have seen some parts of it. So some of the bits that I have demoed may or may not be coming at some point, but it does exist. So if you would like to know more about the roadmap, then I would probably go and ask someone on the Microsoft stand who can put you in touch with the right person.
This is a good one as well, mate.
Thanks.
So, a lot of people are finding Purview a bit expensive for POPs. Is there a way to reduce the cost when going around with it?
So Purview is quite expensive. Is there a way to reduce the cost when playing around with it? And the answer to that is to just keep tearing it down when you're not using it, and to export glossary terms so you can import them later on. But the short answer is that if you need to really get down and dirty with how you're working with Purview, you kind of need to keep it spun up for a while. So prepare to incur some costs. But the good news is it's quite a bit cheaper than other alternatives. Mikey, I've got a question over there. Ooh, that is a good question. How does Purview handle schema drift? I don't know, is the short answer. I know full well that if you put like automated scans on like a regular basis, it will detect those columns. How you then handle those new columns is entirely up to you. So that's my answer. Yeah. Hang on, Mikey.
Is there a workaround?
Yeah.
So when you put the rules together, you have, for example, like the regex or emails. Emails can be a slightly tricky one if you get things like non-Latin characters and things like that. You're sort of multilingual. Is there any built-in rules that help you deal with stuff like that, or is it a case of you need to work out what they are and build them up?
Yeah. So question was. Regex, particularly with emails and non-Latin characters, are there anything built in to detect and handle that? No, you have to do that manually. So you've got to be a regex expert if you want to do that. I'm not a regex expert. If I'm doing it from scratch, I'm going to get it wrong. I need to have a lot of help for that.
I think the next question is really related to an answer that you gave earlier. Is there a workaround to disable or stop Purview without having to delete the account?
No. So yeah, is there a workaround to disable or stop Purview without deleting your account? And the answer is no. Not. Yes. Hang on, sorry.
How does Purview match up against the Unity catalog?
Ooh, how does Purview match up against Unity catalog in Databricks? That is an interesting question, and one which no one's really going to have an answer for a while, because Unity catalog is so brand new that it's not even within private preview yet, I believe. But I think the way that we've been hearing about Unity catalog is that it's just within the Databricks ecosystem. So for it to go out and touch things like SQL servers, whether it's in the cloud or on-prem, it's going to be difficult. But what it might do is provide something which a lot of data governance tools don't do, which is to provide that insight into what Databricks is actually doing with your data. So the actual notebooks and processes which get applied to your data, which some companies claim to do, but I've yet to actually see them do that. There are ways within Purview to register that this, within the lineage of like registering a custom process, that between this data point and this data point, it's gone through this process. And you can say that it's associated with this notebook. But again, that's still like a static image. You still need to go in as an engineer to go into Databricks and then have a look at that notebook itself. Last one.
Is there a
is the community tools for regex expressions which aren't baked into the tool. I mean, there are hundreds and thousands of regex expressions tools. I have no preference. I just Google. So I can't actually give you any advice on which ones to use, but I'm sure Twitter will probably be quite helpful there. Is that it? Cool. Well, thank you very much for your time. I've had great fun. If you want any follow-up questions or conversations around it, I'll be over by the Advanced Analytics stands. So come grab me afterwards for the next couple of hours. And enjoy the rest of your SQL bits. Hope you enjoyed the party this evening. And enjoy.